Hi, welcome to our Honors Geometry playlist. This is our first example of a coordinate proof, at least in video format. So one example of a coordinate proof, well, first of all, a coordinate proof is any proof that uses figures in a coordinate plane and algebra to prove a theorem or a conjecture to be true. So I want to prove that my two triangles are congruent. Well, we know what kind of triangle congruence options we have. We have side, side, side. A classic. We have side, angle, side. A fun twist. We have angle, side, angle. Wow, that's cool. We have angle, angle, side. Where'd that come from? And if we had a right triangle, we could do hypotenuse leg, but we're not doing hypotenuse leg. We would start with our given statements. So I would start with, let D be negative A, comma B. I would let C be negative A, comma 0. I would say let F be 0, comma B over 2. Oh, goodness, I'm running out of room. I'm going to let G be A, comma B, and then I'm going to let H be A, comma 0. Those are my points. Those are my givens. Now, I want to prove that these triangles are congruent. I could do side, side, side. I could do side, angle, side. I could do angle, side, angle. I could do angle, angle, side. I know, first of all, that those two angles should be congruent. So I would say angle DFC is congruent to angle. So DFC, I'd go GFH, because those are vertical angles. So at least I got that down. And now I need either two sides or another angle on a side, or I could even do all three sides if I really wanted to. But I'm going to try to prove side, angle, side. I'm going to try to prove that these two sides are congruent. So maybe I should do a different color there. I'm going to try to prove that those two pairs of sides are congruent. So maybe I'll go with DF and HF. So if I want to prove that those are congruent, I need to prove that they are the same length. So let me find the distance. If I did the distance formula for DF, I could do the square root of, and then I got to subtract, say DF equals, and I want 0 minus negative A, which is like 0 plus A squared, plus, and then I want to do B over 2 minus B squared. So when I simplify that, I get the square root of A squared plus B squared over 4. Because if I were to simplify this, this is B over 2, or negative B over 2. But when you take B over 2 and you square it, you would end up with B squared over 4. That's DF. Well, I want DF to be congruent to HF. So hopefully I can prove that HF has the same length. Well, H to F, that'd be, let's go with A minus 0 squared. I'm going to go with 0 minus B over 2 squared. And now when I square both of those, I get A squared plus B squared over 4. And hey, check that out. DF equals HF. And that is the distance formula. So I can use the distance formula to prove that DF and HF are congruent. And then ideally I would be able to prove, I don't know, maybe I'll use like a dark blue. I'd like to prove that GF and CF are also equal. So let me try that. GF let's see, what is GF? That would be A minus 0 squared, and then B minus B over 2 squared. Well, if you simplify that, that would be the square root of A squared plus B squared over 4. Okay, well, I guess let's try CF. Let's see what happens with CF. I'm going to go with 0 plus A. So I'm going to subtract F minus B, and then B squared over 2 minus 0. And that would get me the square root of A squared plus, and then B squared over 4. And in an absolutely stunning turn of events, what happened here was not only did I get that my two triangles are congruent, because I can show here, let me erase some of this extra stuff down the bottom, I can show here, as I just did, that not only are, I should do this in pink, not only are these two sides are congruent, and those two sides are congruent, I have 4 pairs of sides. Right, I've got 4 sides here, or 2 pairs of sides rather. I have 4 sides in total that are all the same length, and I've already proven that those angles are congruent, so I have side-angle-side congruence, and I have isosceles triangles, so that's pretty cool. I can say that triangle, what am I trying to prove here? Where is it? Triangle FGH is congruent to triangle, that's an ugly triangle, triangle FDC, and those are congruent by side angle side, which is honestly pretty fascinating. And if they asked me to prove anything else, I could just use either my corresponding parts of congruent triangles are congruent, my CPCTC, or right, if they had asked me to prove that those triangles are isosceles, I'd also proven that one. So that's a pretty interesting result. I like that one. Stay tuned for some more videos later this week.